All right, let's dive into something that might just mess with your head a little bit. Optical illusions. What we're about to explore really challenges the very way you see the world. So take a good look at this. I mean, really look. It feels like it's swirling, right? The shapes look like they're just in constant flowing motion. But are they? Here's the crazy part. It's not moving, not one bit. The image is perfectly still. So if your eyes are telling you one thing and reality is another, what on earth is going on? And that right there brings up a huge question, maybe the biggest one of all when it comes to perception. Can you actually trust your own eyes? Let's dig into that gap between what you see and what's really there. So you've got to be asking, right? If the picture's not moving, is there something wrong with my eyes? Is my vision just faulty? It's a totally fair question. But the answer, believe me, is way, way cooler than that. It has everything to do with the most complex thing in the known universe. Yeah, it's all happening inside your brain. Because seeing isn't just about your eyes taking a picture of the world. It's an active, and I mean really active process where your brain is constantly interpreting and, well, guessing. Okay, here's the best way to think about it. Your eyes, they're just the cameras. They collect all the raw footage, light, shapes, colors, all that stuff. But your brain, your brain is the director. It takes all that messy, raw data, starts editing, fills in the missing pieces, and basically creates the entire movie that you experience as reality. And that's the absolute key to understanding all of this. These illusions, they don't actually fool your eyes. They fool the director. They're designed to fool the complex, predictive machine that's doing all the real work behind the scenes. So why does our super smart brain get fooled so easily? Well, honestly, it's a feature, not a bug. Your brain is built for one thing above all else: speed. To keep you alive, it has to make lightning-fast judgments. And to do that, it uses all these clever little shortcuts. I mean, just imagine for a second, if your brain had to analyze every single pixel of information coming in from scratch, you wouldn't even be able to walk across a room. So instead, it cheats. It uses patterns it already knows, taps into your memory, looks at the context of a situation, and makes a really, really good guess about what you're seeing. Most of the time, it's perfect. But every now and then, that guess is wrong. And these shortcuts actually have a name. They're often called Gestalt principles, which are basically the brain's internal rules for making sense of a messy world. Like closure. That's how you can see a whole shape even when parts are missing. Or proximity, where you see things that are close together as a group. You've got similarity, continuation, and figure/ground. That's the classic one where you separate an object from its background, like in that famous vase or faces image. Optical illusions are so powerful because they basically hijack these very rules your brain lives by. Okay, so that's the theory, but let's actually see this stuff in action. It's way more fun to break down some of the classics. All right, check out these two lines. One's got the arrows pointing in, one's got them pointing out. Just go with your gut feeling. Which of those middle horizontal lines looks longer to you? You ready for this? They're exactly the same length. No, seriously, if you have a ruler handy, go ahead and check it out. They are identical. This is the famous Mueller-Lyer illusion, and it's just a perfect showcase of your brain's shortcuts going a little haywire. So what is going on here? Well, it all comes down to context. Your brain has spent your entire life looking at corners. Those inward-pointing arrows, they look kind of like the far corner of a room, right? And the outward-pointing ones, they look like the near corner of a building poking out at you. So your brain automatically applies its 3D depth perception rules to this flat 2D image. It thinks, hey, that line looks farther away, so it must actually be bigger. And boom, it literally changes your perception to make that line look longer. Okay, you ready for another one? Let's try this. Look at squares A and B on this checkerboard. One is clearly in a shadow, but are they actually the same shade of gray? Yup, you probably saw this coming. They are the exact same shade of gray. What's happening is your brain knows that things in a shadow should look darker than they really are, so it automatically compensates. It brightens square B inside your mind before you even see it. Your brain is trusting the context, the shadow, more than the raw color data coming from your eyes. Isn't that wild? So these things are really cool, but they're not just fun party tricks. For scientists, illusions are like these amazing windows right into the inner workings of the human mind. You can actually sort them into three main buckets. You've got your literal illusions, which is like when you see a face in the clouds. Your brain is just finding a familiar pattern. Then there are physiological ones, like that moving image we started with. That's just your eyes and brain getting overstimulated. And then you have the cognitive illusions, like the two we just looked at, where the brain itself makes a wrong assumption based on what it thinks it knows.
And by studying all of these, scientists learn some pretty incredible things, like how our memories literally change what we perceive. They've been able to prove that our brain is basically a prediction machine, not a recording device. And they can see how our minds handle confusing or ambiguous info, which even gives us hints about things like creativity and how we solve problems.
So where does this leave us? What's the big takeaway here?
Well, it pretty much forces us to completely redefine what it even means to see something.
Because here's the bottom line. Your vision isn't just biology. It's part biology and it's part psychology. What you perceive isn't just what's out there. It's a mix, a collaboration between what's actually there and what your brain expects to be there based on everything you've ever experienced. And I absolutely love this way of thinking about it. Your vision isn't a perfect recording of reality. It's a creative reconstruction. You're not a passive camera. You are an active artist, constantly building the world you experience. So, the next time an optical illusion trips you up, don't think of it as your brain failing or making a mistake. Think of it as a beautiful little clue, a glimpse under the hood at the incredible, powerful, predictive machine that's running the whole show. And that, of course, leaves us with one last kind of mind-bending question to chew on. If your brain is literally constructing the reality you see, what else is it constructing?